All right. Now, if you notice here, I have written something called loop. Actually, it is loop back 0. See, this is not loop back address. You remember when we learned IP addressing, 127 any number is loop back. I'm not talking about loop back address. This is an interface, a logical, not physical, to which I'm giving this IP address. Because it is not physical, I cannot see. Because it is not physical, if I cannot see, I cannot connect a device like this. See, I have connected a device to this port because that's a seeable one. I can see that. It's a visible one. It's a physical port. We connect a computer, sorry, we connect a wire and we will have many computers. If you have a switch, you will have many computers to that particular port. But this is a logical port. You cannot connect any computer. So we can mask 32 because you don't need any more IP address in that network. This is one logical interface. It needs an IP address. Can you connect and have more device in that network? No, it's not a physical port. I cannot connect. If it is physical port, I can connect and I can have more computers. So I need more IP address. That's why I have /8. But this is not a physical port. So there is no need for another address starting with 1 or another address starting with 2. All right, I would like to keep this loop at 1. This is just an idea of that interface, like you have G000, G001, like an ID you have to differentiate the port. This loopback also can be differentiated with 0, 1 numbers. See, what all I have said so far is loopback is a logical interface to which you can give an IP address. But you cannot connect any device to that interface because it is not physical. So there is no need for more address in that network. So you can mask it to 32. You can mask it. All the loopbacks can be masked to 32. And that 0 and this 1, 2 and all to differentiate that interface. It's an interface name. Loopback 0, loopback 1. You can give any number. You can give any number. It need not to be always starting with 0 and the next one is 1 and the next one is 2. I'm just following an order, but that's not needed. If you say I wish to have a number 10, yeah, you can have a loopback 10. I wish to have loopback 11, no problem. These two are two different logical interfaces. Now, question is in your mind, why do we need a logical interface when I cannot connect a device to it? I have an interface here, I'm connecting a device here. There is some meaning in it. What is the use of a loopback interface? What is the use of this loopback interface? Is this may be a question in your mind? What is the use of loopback interface? Why do we need this logical interface? See, just for testing, I need some network. I have 30 already. I have 10 already. I want to have 2 more networks in this router, but I don't want to waste a physical port. I just want to have this network so that I can ping from here 1.1.1.1. Ping from here 2.2.2.2. Just I want these 2 network on this router. not to have a LAN, but to simply check the reachability of that router. I call this as router A. Router B. Routers. Okay. So now tell me how many networks are there in our topology? Totally, how many networks do you have? So I did not ask how many are configured. Nothing is configured. How many are in the topology? I asked. There are 8 networks now. We have 8 networks. 4 loopbacks. Each loopback has got a network. 1, 2, 3, 4, 5, 6, 7, 8 networks. Now try to answer at least to yourself. In this router, as soon as I give these IP address, how many networks I will see in the routing table? 4 only, which is 1.1.1.1/32 on loopback 0 interface, 2.2.2.2/32 on loopback 1 interface, 10.0.0.0/8 on G000 interface, and 30.0.0.0/8 on G0/0/1 interface. Likewise, on router C, I will have 4. What are they? 3.3.3.3 on loopback 0, 4.4.4.4 on loopback 1, and then 20.0.0.0/8 on G0/0/0, and 40.0.0.0/8 on G0/0/1. And in the middle router, connected, only 2 networks connected, 10 via G000, 20 via G001. This is what is going to be after we finish configuring the IP address. Okay, now I'm going to configure on one router the IP address. After that, I'll give you time for you to configure on all 3 routers. After which, you're going to check this by typing show IP route command on all these 3 routers. All right. I am starting this configuration from this PC. This PC IP should be 30.0.0.1 and the mask is 255.0.0.0 and the gateway is 30.0.0.2. Is this right, Priya? 30.0.0.2? Yes. So that is where this PC is connected, 30.0.0.2. IP config. I want to verify. Yeah, it is correct. Taken. Next is I would like to go to this router and put the IP address. Enable host name router A, interface G000, I bring it up and I put IP address. What IP address I should put here? Hmm. Done. Next. Uh, what happened? Exit. Okay. Interface G001 IP address 30.0.0. See, I have given IP address to two physical interfaces. And I also said no shutdown. Now is the important time. We are going to create this loopback. Before I create, I want to show you the status. Show IP interface brief. You see here, two physical interface has got IP address. Why this is down? Why is this down here? Any answer? Because R2 RB is not configured, the port is down that side. So no protocol is running. So let's not focus on that now. Do we have any interface called loopback mentioned here? No, you don't have. We are going to create, you see, interface loopback. You can put any number between 0 to 2147483647. You can give any number. You can give any number. Do you see this range? Oh, how big it is? You can use any number to identify the loopback interface. I'm going to identify first by using loopback 0. You can start from 0. You see, as soon as I hit enter, it has created an interface and line protocol is also up. You no need to say no shutdown to a loopback interface. You no need to say no shutdown to loopback interface because it's a logical one, because it is created by your own fingers. It is up. Now I'm going to give IP address same like what I used to give on the physical interface. 1.1.1.1. But the difference is I'm masking it completely 32 because I cannot have any other device connected to this port. It's a logical port. Now let us go and verify this. Show IP interface brief. Look at this. This was not there earlier. And it is up. All right. Both status as well as protocol, both are up. Let's create another one. Interface loopback one. IP space address 2.2.2.2. Done. Let us verify now. Show IP interface brief. You see, you've got this. I'm also parallelly configuring here. If you have any doubt, you can see me configuring this if needed. That's 30.20.0.2. Put 30. Okay, I finished my configuration. Have you finished? Let me check from my side on my routing table on route ratio IP route. I have 4 networks connected. You see 111, 222, 10, and 30. 30 is the set. Okay. On B, I should see 2. Show IP route. I can see 10 and 20. Is it 20? Yeah, 20. On C, I should see 40 and 20. Show IP route. Okay, 3. If you notice the routing table, it will always arrange like this. Small one first, and the next biggest, and the next biggest. That's the order in which you will see the display. Okay, so if these are there, we are ready to go with the static routing. Let me explain you what we are going to do now, then we can do. So focus on the board. The question is, if I want to ping from here to anywhere, how many more networks this router need to know? If router A needs to reach all the networks, how many more routes I have to have in the routing table? You remember last class we wrote static route, only one route we wrote. Because in our topology, the previous class, there was only one unknown network. So we were writing one network, one static route. Here, for how many networks this router do not have the route, and how many routes I have to write. We have 8 networks, but this router knows only route for 4. So I have to write 4 static route. All right. I have to write 4 static route. For which all network? For 20. See, this do not know about 20. So I have to write static route saying 20 network. Where should the packet to be forwarded? To this address. Next, another static route to 40 network. If it wants to go to 40 network, where should router A forward it? Not to C. It cannot go directly to C. No. It cannot. It has to send it to this address, same address, 10.0.0.2. Again, static. To 3 network, if the packet needs to go, where should the packet to be forwarded? It needs to be forwarded to router B. What is the address? Same 10.0.0.2. Next, what is the 4th network we need to write route? 4444. So static route, in order to go to 4 network, send the packet to router B, which is 10.0.0.2. 10.0.0.2. These many routes we need to write statically. Now tell me how many networks this router do not know. Ria is waiting for Pavitra. Yeah, 20.0.0.1. But what if I don't know this address? What if, Azim, I don't know this address? So there is an option. If you don't know the address of the next router, you can put this exit interface address. Is this the exit interface towards the destination? Yes. To go to all these destination, what is the exit interface from this router? This G000. So I can say go via G000. This is only if you do not know the other route, next router's address. But you cannot give your address. No, you should not give your own address. If you know the next router's address, you give. If not, you give your exit interface address. Did you get this, Priya, Pavitra? Did you get this? கட்டாயம் சொல்றேன். பாருங்க, இந்த நாலுமே இந்த திசையில தானே இருக்கு. 30, 10, 1. அப்போ இந்த திசையிலனா, இந்த திசையில போகணும்னா எந்த இன்டர்ஃபேஸ் வழியா நீங்க வெளியே வருவீங்க? இந்த இன்டர்ஃபேஸ் வழியா தானே வெளியே வருவீங்க. அதுக்குதான் எக்ஸிட் இன்டர்ஃபேஸ் சொல்றோம். எக்ஸிட் இன்டர்ஃபேஸ் எழுதினாலும் ஓகே, இல்ல அடுத்த ரவுட்டர் அட்ரஸ் தெரியும்னு சொன்னா இங்க எழுதணும்ல அடுத்த ரவுட்டர் அட்ரஸ், இங்க எழுதணும்ல அடுத்த ரவுட்டர் அட்ரஸ். அந்த மாதிரி எழுதுறதுக்கு அடுத்த ரவுட்டர் அட்ரஸ் நமக்கு தெரிஞ்சாதானே. இப்போ ரவுட்டர் பில 10.0.0.1 10.0.0.2 இருக்கு எழுதிட்டோம், நமக்கு தெரியும் எழுதணும். ஒருவேளை இது நமக்கு மறைக்கப்பட்டிருந்தா, நமக்கு சொல்லலைன்னா, இது வேற அட்மினிஸ்ட்ரேட்டரா இருந்து அவன் நமக்கு சொல்லலைன்னா, என் அட்ரஸ் இதுதான் 20.0.0.1 சொல்லலைன்னா என்ன செய்யறதுன்னா, நம்ம எக்ஸிட் இன்டர்ஃபேஸ்ல கொடுத்தா போதும். நம்ம எக்ஸிட் இன்டர்ஃபேஸ்ல இருக்க அட்ரஸ் கிடையாது, அட்ரஸ் கொடுக்க கூடாது. அட்ரஸா கொடுக்கறதா இருந்தா அடுத்த ரவுட்டருடைய அட்ரஸ், அடுத்த ரவுட்டருடைய அட்ரஸ் கொடுக்கறது நல்லது. எனக்கு அடுத்த ரவுட்டருடைய அட்ரஸ் தெரியாது அப்படின்னு சொன்னா உங்க எக்ஸிட் இன்டர்ஃபேஸ் எதுன்னு பார்த்து அதை கொடுக்கணும். G000. புரிஞ்சுதா? Now you see, for all these destinations, which address is gateway? $10.0.0.2. See, not only to this 4, even if there is 100 networks added here, this is the only gateway. Do you understand? For router A, this is the only gateway, correct? In such cases, we call our router as stub router. We call this type of router which has got only one gateway For all unknown destination, if you have only one gateway for all unknown destination, we call it as what? Stub router. Stub. Router B is not a stub router because some unknown destinations are towards the left, the other are towards the right. This is not a stub router. Is router C a stub router? Correct. Now listen carefully. In stub router, instead of writing like this, you can simply tell all the networks that are unknown. This is what called as any network. This router do not know. Just send the packet to 10.0.0.2. Simple. In one line you can finish. Any, this means what? 0.0.0 means what? Any network, any subnet mask. Writing like this is what called as default static route. So on stub routers, only on stub routers, you can write this default static route. Yesterday you learned how to write static route. That you should write on the middle router. Because middle router, you cannot write default route. Why? Some are in left, some are in right side. Some destination are in right side, some are in left side. So you should not write like that. But on the stub routers like RA and RC, you no need to write these many lines. You can tell that any routes that you do not know, we call it as static default. Default will have star like this. Static route will have simply S. Default will have star. Command is same only what you did yesterday. Is your wish. If you know the next router address, you write. If not, you write your exit interface address. Is this understood? Do you understand this? Okay. I'm going to do this and show you. Afterwards, you can do. On router A, we are not going to write detailed routes. We are going to write only default route. How to write it? IP route, any destination, any subnet mask it can be. Just send it to 20.0.0.2. See, that's the IP. Sorry, 10.0.0.2. 20.10. I'm sending it to B, router B. That's all. Let us verify this. Show IP route. You see, S star. Star means what? Candidate default. S means what? Static. Static. Right? Now, can I write a default route on RC or not? Yes. On RC, I'm not going to use the next router's address as I'm pretending as if I do not know. So what I do, IP route, any network, any subnet mask, push it out via G0.0.0. You see, I said G0.0.0, send it out via, but it shows one warning message. It is just a message. Don't take it too serious. It says, "Yampa, அடுத்த router address நீ கொடுக்காம interface address கொடுக்குற point to point இருந்தா பரவாயில்ல. இது கிட்டத்தட்ட point to point மாதிரி தான் இருக்கு. இங்க கிளம்புனா இங்க தான் போகும். Do you have any other third router in between? No. You can do this, nothing wrong. So it is not an error. It is just telling the அடுத்த router address கொடுத்திருந்தா நல்லா இருக்கும். இருந்தாலும் பரவாயில்ல, பாயிண்ட் டு பாயிண்டா இருந்தா பரவாயில்ல அப்படின்னு சொல்லுது. சரி, next. Let's verify. Show IP route. You can see here a default route. It is pointing towards G0. It is just going out on G000. See the routing table difference. Here it says directly connected, whereas in router 1 it says via this address. And you see a number in the bracket, but you don't see such thing here. I'll explain you what is this number later. Now it is not necessary. So if you are using exit interface, you won't have this number called administrative distance. No need to focus on that now. But this is also a star. This is also default route. That is also default route. The difference is here I have given the router C's exit interface. Here I have given next router address. Okay. Now on router B, we have to write 6 routes. IP route. If you are going to one network, if the traffic needs to go to one network, send it to 10.0.0.1. Am I right? Send it to 10.0.0.1. That's what we have written here. Likewise for 2 network and 30 network. I'm going to write. So simple. I'll use the up arrow. Use the up arrow key and delete this portion and say 2.2.2.2. Enter. And then again use the up arrow. Change this mask to /8 and this to 30. Okay, 3 routes towards the left is already done. This is done. This is done. This is done. Now the other 3 routes are towards the other direction. IP route. If the traffic needs to go to 4 or 3, first let's write 3. There is no sequence actually, but I'm just simply following. Where should I send? According to the topology, I have to send it to 20.0.0.2. Likewise, 4.4.4.4. Likewise, what's the third network? 40. For 40 also I have to send it to 20.0.0.2. What is the mask for 40? /8. Do you follow? Is it easy? Okay, done. Now let's verify the routing table. Show IP route. Look at this. We have written 1, 2, 3, 4, 5, and 6. This 30 is going towards the left. 1 and 2 also goes towards the left. 3, 4 is going towards the right. Also 40 goes towards the right. Now, if I ping from this PC, I will be able to ping anywhere. Listen, I'm in 30.0.0.1. I'm going to ping now the second router, which is 10.0.0.2. I'm just showing you one by one, one by one, one by one. This is router B. I'm able to ping router B. And I want to ping router C. Router C address is what? 20.0.0.2. So from this PC, I'm pinging to router C. I'm able to ping. And now I'll try to ping 40.0.0.1 from that PC. 40.0.0.1. Oh no, 1. I will ping. It should ping. It is pinging. Now what about this one? 333. Can I ping? Yes, I can ping. From this PC, I want to ping that loopback of that third router. I'm able to ping. See, it is responding same like one computer is sitting there. It's not there actually. It's a logical interface. 444. I'm able to ping. You see, though this router A don't have root for 4444, is there a root for 4444 30? Sorry, 3333 or 4000? No, there is no root, but there is a default route. This says anything which is not matching here, anything, just send it to here. That's why even from here, if I try pinging 4444, even though there is no root, I will be able to ping. You see, I'm able to ping. I can ping 40 from here. When I don't have root, I'm able to ping. There is no root actually, a precise route for 40, but I have a default route for 40. Not only for 40, for any unknown destination, that default route, this default route can take to any unknown destination. And it will send to next router. If next router knows, good, you will be able to reach. Is this clear?